Welcome to the 8th Science Industry Roundtable organized by the European Lime Association. The topic of this roundtable is Masonry and Eurocode 6, aiming at preparing ourselves to the discussions of the next national annexes of these standards. For evident sanitary reasons, the format of this roundtable is different. It is organized in 5 thematic short sessions, out of which at least 4 will be held virtually. The sessions will be recorded and will be made available. Today's introductory session is on the future of Masonry. Professor Paulo Lourenço from Minho University will present us his vision on the future of Masonry and highlight the evolution of Eurocode 6. Then we will have a discussion with a panel of experts from the brick, block, and mortar industry. The discussion will be moderated by Professor Lourenço. Your questions are welcome via the YouTube chat function. The following 3 sessions will be thematic on mortar masonry bond, formulation impact, and execution and quality control. The final session is aiming to exchange on the national annexes of Eurocode 6. The format of this session is not yet fully decided, as we are still hoping to be able to organize this session likewise our traditional roundtables, with physical presence and hopefully in March. The decision on date and final format will be taken within the next weeks. Do not hesitate to come back to us with suggestions concerning this new type of organization and link with persons who might wish to join our discussions. I now give the floor to Professor Lourenço and wish us all interesting and fruitful discussions.
Okay. Well, thank you. I would like obviously to thank EuLA for the invitation to be here. And I will try to share with you some vision of the masonry developments and what has been introduced recently in the new European Masonry Code. I will start with a brief overview about civil engineering and construction. This is a major industry worldwide. Roughly in Europe is about 10% of the wealth. And as you can see, it's about, 30% of the industrial employment. It is indeed the biggest industrial employer in Europe, and it is a major exporter in Europe, both as services and as products. And so it's a very important sector to our economy. And it has been recognized as so. And so sometimes people address the past century as the century for construction because we never built so much. And it changed the way we live as a society. So not only in terms of mobility, in terms of health, in terms of quality of life and comfort of our lives, in terms of also of life expectancy. But still construction doesn't have often a very good impression from the society. And society tends, and the public tends to think about construction as a system which is partly inefficient, very low technology, and not very prone to innovation. It is a very highly regulated sector, but it is responsible for many innovations in the recent decades and in the decades to come for sure. Now, the next century, or this century, is obviously a century where the world is global, where innovation plays a key role for our societies, and there are many changes in construction. Obviously, one change, as I will address further, is a change to conservation and maintenance, because a lot of the built heritage in Europe has already been built. Another major concern, which has been here for decades, is sustainability. So this is the buzzword for years. Now people talk about resilience a lot, and this means how can a society survive the disaster and regains an acceptable level of performance. So once you have a disaster, disasters are inevitable and we have to prepare for them. But once we have a disaster, how can we recover? So this is a very recent buzzword that construction should also address. And then there are many new words and recent words. Obviously, the digital transformation or the Industry 4.0 is one of it. But there are many other words that are around us, from cyber-physical systems, Internet of Things, big data, artificial intelligence, additive manufacturing, and of course, you know, the circular economy or decarbonization. So there's many new things that are affecting the way we live and the way the industry will progress. There are some bad news on construction. Not only it is obviously a major use of resources and responsible for a large percentage of the energy consumption and CO2 emission, but in fact, when we look back, it has been a sector that has not increased the productive as it should compared to other sectors. And so construction is, similar to agriculture, one of the least digitized and the one in which productivity actually decreased in the last decades. And this is something that we have to look into. And when you look as what things will change the world of construction, and this is a survey from the construction companies, you can see that exciting photos and videos that we see sometimes of totally making a new building is on my left corner. So the contour crafting and making integrally a building is not understood by the industry as very likely and having a major impact. But there are other things that are very likely and will have a huge impact. And you can see on the right corner. And this includes BIM, or the building information modeling, includes prefabrication, includes real-time collaboration, and many other things. And so there will be a change in the construction sector, and we all need to be a part of it in order to make the sector alive. And it is amazing to see in the last years how the big world players are joining construction. You have here Google, we have here Amazon, we have here IKEA. And so all of us know IKEA and I think the furniture, but they want to be a global player in housing. And as you can see, they want to provide sustainable, quality, and low price, which are for all. At the moment, their production is relatively small, so we're talking about 1,200 houses per year, but this will increase. And the same Amazon is investing in startups. And so this might change part of the way we're producing houses in the future. Now, when we look at the European market, and this is not the market in Europe, but this is the market that the European companies basically work on. And this is a global market divided in the world and divided in different categories. But when you look at housing, which I'll be focusing here today, you can see rehabilitation and maintenance is 26% and new housing is 23%. And so this means, because rehabilitation of maintenance here is in housing, actually, the European industry spends more money or gets more turnover from rehabilitation and maintenance than from new housing, which seems quite evident given the European market and the fact that it has been built for long. Now, there are a lot of exciting news from the world and from the way our societies are developing. I have here a few sentences that I will not detail, but two of them are quite important. One of them, which is a prediction from the US National Academy of Sciences, they projected some years ago that in the next 50 years, we will build as much as we built in the last 10,000. So basically they are saying we're going to double housing, and to double housing, basically the history of construction and civilization is 10,000 years. So the pressure for the world and the pressure for the societies in building will be enormous and will remain. The last sentence is also important because the population is moving to the cities. And so sometimes the housing is not where we want it to be. And so the demand will be to make the very large cities and to have a lot of people living together. And this is, again, will require a lot of construction activity. Now, when we talk about housing, here you can see a distribution of the housing stock in Europe. And you can see that most people live in single-family houses or multi-family houses. And so the high-rise buildings are not very typical. Only 10% live in high-rise buildings. And a lot of people, half of the population, actually live in small houses. And obviously, masonry is very adequate for small buildings as a structural material. The buildings you see on the right, masonry is not a structural material, it's an infill material or is a cladding material, which is also, of course, a very important part of the market. But structural masonry in high-rise buildings is not very common, exception of a few countries. And so masonry obviously remains much used, but faces many challenges with other products which are competing, and sometimes they can replace masonry. And when we talk about masonry and ask other people, well, what do they think about masonry? Well, solidity is a word that comes a lot. It's a solid material. It's also incombustible. So fire protection or fire resistance is quite high, which is very good. Well, a lot of people think about it as durable. It has a material that has been around again for 10,000 years. And some people also look at it as an aesthetic material, okay? Now, it's not only good things. There are also many things that people think negatively about masonry. One of them is that it's an old material and that's low tech, and people tend to think about masonry as something that is around in a very similar way for a long time. And people tend to think about something which is slow to build, and it's very labor intensive. And labor is not only very expensive in Europe, but it's very difficult to find people to work in the construction sector. Well, many people also think about masonry negatively because of earthquakes. And so masonry construction is much used today, and it can be perfectly used in earthquake-prone countries. But there are two facts here, which, in my view, we cannot deny. And fact one is that earthquakes are the deadliest natural disaster. So they are responsible for 40% of the deaths when you think about natural disasters. The fact two is that 60% of these deaths, or the majority, are due to masonry building. And so it's not the fact that we can build masonry properly today by using modern regulation, is that much of what was built in the past is not adequate in terms of vulnerability against earthquakes. And here I collected with one of my coworkers, Dr. Rui Marques, an attempt to understand if there is a link between earthquakes, or let's say in technical terms, seismic hazard. So if you have a lot of hazard from earthquakes and unreinforced masonry. And there seems to be not such a link. So some countries which are low hazard, they use masonry. Some countries which are, well, with low hazard, they don't use masonry. And so some countries which are medium or medium to high, they also use unreinforced masonry. So there's no direct link. And in my view, I mean, as a researcher and also partly as a professional, I don't see a problem to build unreinforced masonry buildings which are earthquake resistant. We have enough information to do it. Now, more bad news on the public side, I will go fast to the good news, is that, well, the best of 2019 was that concrete is the most destructive material on earth. And this is not very nice for the construction sector. So there's a lot of pressure of society. And it's amazing that everybody talks about construction because of the impact it has in societies. For example, the French government would like to make all public buildings made at least 50% of wood. And this is a major change. And in fact, the question is, do we have enough wood in the world to build in wood? And it doesn't seem so. At least wood that is properly harvested. And so you can see the European Green Deal, which is making clear that not only carbon has to be paid, so carbon has a price because nature cannot pay the price anymore. And the question is, when you think about carbon, immediately you think about steel and cement, which are basic materials for the building industry. And obviously the question is, can you import cement or can you import steel from other countries where the regulations are different? And the European Union will not be in favor of that. And so the carbon tax will have to be paid everywhere. And this is the most recent statement, which I think is important in this context, from the President of the European Commission, of the European Union. And she says that, we need a new European Bauhaus. So this is about bringing the European Green Deal closer to people and homes. And again, the politicians are always thinking about the building sector. And when you think about, you see about the new European Bauhaus, most of the things they speak about is linked to construction, natural building materials, energy efficient. Demographics is also linked to construction. We did new houses, okay? Digital innovation, resource efficiency, etc. Now, they would like to renovate in the 10 next years, 400 buildings per hour. This is an amazing number, the investment that will be put in construction to ensure energy efficiency. And this has to be continuing because there's this desire to make Europe the first carbon neutral continent in 2050. And so there's a lot of investment in construction and bright days ahead for the sector, in my view. Now, when we talk about masonry and the future, where to go, it's a key issue. And I put here some beautiful photos of things which are not the answer for sure. So we will not have masonry solving these problems. I'm a strong believer in the link between academia and industry. I don't think academia today, at least in the engineering sector, because academia has many sectors and some of them are less linked with the industry, I don't think we should work independently. I think we need to work together. I can understand that innovation has a cost for the company. So you first put money to get money. But if you don't put money, you don't get money. And then the industry is gone, because if they are not innovative, they will be replaced. Now, I show you here two products which I'm proud to have worked with. One product is, I think, extremely actual, and it's a patent product that only uses waste, okay? So everything in the product except part of the aggregate is waste, but most of it is waste to replace masonry infills, non-structural. And the second product, which I think is a very nice, let's say, global story for masonry. I mean, the question is, if the masonry market doesn't solve the problem and people do like masonry, well, they will solve it in another way. So obviously that we can do, just dry infills, gypsum infills, and make them look like masonry. That is very simple today. And they even say that the brick slips will solve our problems. Also, if people like a masonry vault, well, you can also do it in a polymer. So why do I have to do it in brick? And so this is a major danger, in the sense that if the industry is not innovative enough, people will try to replace for something which is easier, cheaper, and in some cases, even more energy efficient. Now, we try to address this problem of curved elements with a product which I'm very proud of, which is the FlexiBrick, which it was used 3 times in a row by the Spanish Association of Brick Producers. So they liked very much our product. They made these amazing booths in industry fairs, and the product was a failure. Now, it was a failure for the original idea, which was to make curved, let's say, elements made of masonry that you can see here in the right. And the product was a success. In the left, which is another or a spillover effect of our ideas. And so the product failed to develop curved surfaces made of masonry, but the product was successful to be used for gardens or to be used as shading. And the product is successful and it's selling And so this is, I think, an example of how innovation could go in another direction. So I think it's also very important to be open to. Now, there's many exciting examples of a new world. I put here some pictures. I will only say something about the one on the left, which is a company in Canada where Amazon and Microsoft put over $1 billion as a venture capital. And so you can see that everybody is interested in construction. So we just need good ideas. This is other ideas which I think are quite important, and it's a challenge for Europe. When you think about building information modeling, I would say, for example, the Masonry Society in the US, they have a building information modeling committee for a long time. And it is easier in the US where the products are more similar. In Europe and across the world, Masonry is so different that it creates a lot of problems, for example, to put it in Autodesk or in Revit, and to have it easily applicable to all professionals in the world, because sometimes it's too market specific. The same happens, for example, in dry mortars. You can see that most of the market is not obviously for masonry joints, it will be for plasters or for tiling. And then in Europe, the market is mostly dry mix, but if you go to the world, it's not certainly mostly dry mix and is still small percentages, depending where you are in the world. And so there's many things to be done and many developments. There's many new products being developed, a lot of them addressing energy efficiency, large products with large resistance. Of course, we have the products that we can install very fast, that also pose challenges, for example, by not filling vertical joints. We have many exciting new products in reinforced masonry that allows us to do different things. Some of these products are quite new, but they have implications in the code. They have implications how we can use them. And so, well, masonry construction, in my understanding, still has a large application. It has a lot of challenges to be competitive, to remain competitive with other products. And it has also a problem then when you need the code to apply it, that the code may be able to accommodate the innovation. Now, I'm going to speak very briefly on masonry codes. The Eurocodes, for those that are not aware, are a set of codes that have been developed in Europe with the aim that services could be basically transferred over across Europe as a common market. They had also this spillover effect, and so they are adopted in many countries which are not in Europe, and there's expression of interest in many countries which are also not in Europe. So of course, for the world, it would be very nice to have common codes that would ensure that our houses, normally the largest investment of the population, and let's say the household is their most precious possession, and we should be sure that it has adequate safety and adequate performance in terms of all other requirements, durability, fire, acoustic, thermal, etc. And so for this, we need codes, certainly. And the codes are very general, so they basically address all types of materials. The European masonry codes, they have been developed partly based on the experience of the countries, like the British standards, like the German, like the Italians. And so they change or they develop their codes independently, and then we try to merge them together. But there are many countries around the world, and some of them still remain developing, even in Europe. So the US code, is much based on reinforced masonry, so it's quite different from the codes we have in Europe. And this code is together with commentaries, which is a kind of user of the code. We have, for example, many codes in Latin America, which they consider extremely, well, the market is very large, for example, in confined masonry, which is far less popular in Europe. And of course, another good example of a code is the Italian code that has been developed for a long time for the case of earthquakes, because they had recurrently destructive earthquakes. And the Italian code, for years, it has been the most advanced code in terms of earthquake engineering of unreinforced masonry structures, which will be the base in some way to the next European code, which is being developed. Now, some remarks about Eurocode 6. Well, the Eurocode 6 has basically 4 parts. One which is general rules, one which is fire, one which is execution and materials, and one which is simplified calculation methods. So the last one, simplified calculation, is not used in many countries. So basically you have the general rules, the fire, and the execution parts. I'll be talking a little bit on the general rules. So the form of the code is constant for all the codes of different materials, from concrete to steel, etc. So basically you have some general section, then you have materials, durability, analysis, and how to design for ultimate and for stability, and then also something on detailing and execution. The code by itself requires training, and this is a major problem because in many countries across the world, structural masonry or masonry is very weakly taught in engineering or architecture. And so many of the professionals have low knowledge about these materials. For example, in UK, there is a website which is sponsored by the industry to help people to use the code. Because if you have untrained engineers and if you have not much help, then the codes are quite difficult to use by themselves. In Europe, we have also examples of books which help designers to use the codes. And the team that I was very happy to be the convener is here in the screen. And Rob van der Plujm, which is actually the chairman of the subcommittee of masonry of the Eurocodes, who will be speaking after me. And so basically, we address these issues. And these are the issues that were contracted, ideally by professionals and by the industry and by the academics. So they would like to reduce the number of national determined parameters to make the code easier to use. Well, there was many issues related to masonry material properties, and particularly some changes and to accommodate innovative products. There are some issues related with complex shapes, confined masonry, and let's say out of plane and slenderness, and some issues related with sustainability, which is also quite important because when you try to bring aspects like thermal performance to the masonry, sometimes you end up with solutions that the code was not originally conceived for. And so I would like to spend a couple of minutes only on what is an NDP, because I think it's important for discussion. The Eurocodes have a structure which has been agreed by all countries, but then the different countries have the possibility to add an annex. And in the annex, there are a few parameters which are called NDPs that the countries can decide freely, okay? So they can replace the code in those parameters. And this is common in all codes. You can see that for all the codes, there is national determined parameters. And you can see that depending on the country you are from, that in some of them, they basically adopt the recommended values, but in some of them, they change a lot the recommended values. So the blue ones are the adopting most, and the orange ones are the ones that adopt less, the recommended values. And I would like to show you 2 things which I think are interesting for masonry for the discussion. For example, when you think of something very easy, which I think should be very easy, which is defining the mortar strength, well, the countries are totally in disagreement because they consider a lot of different mortar strengths that may be used on practice and are in the national annex, and the mixes for that number. So if you have an M10, which now is gone, but indicates a mortar with 10 megapascal compressive strength, the codes have very different opinions on what is the mix that gives this, okay? Another example that I would like to show you is, for example, compressive strength. Now, compressive strength of masonry is basically the most used parameter because it's used for quality control. It's used to give you an idea of, let's say, the quality of a brick and of a block and of a mortar. And you can see there is a formula that gives you the compressive strength of the masonry as a function of the block or the brick and the mortar. And you can see that countries have very different ideas on the formulas to use. And the worst thing is when you plot these formulas, you can see that the scatter in properties, for example, for a given clay brick and different mortar classes, is too large because the scatter is from 1 to 2, basically. And this is hardly acceptable. And so this means that the practices are still in some way not fully stabilized. Other issues that were important in the code is the shear resistance. I will not go into detail, but I think there was a significant improvement in the shear resistance. There was a significant improvement in second order effects because the current code was not, well, very reasonable. And so this is a topic that was addressed, I think, properly. And also confined masonry was significantly extended to the level, for example, that it is used in other codes in the world because the code was very limited in that aspect. I'm in the end of my time. I would like to make a couple of conclusions. So these are the conclusions related to what was done in the code that I will not go into details. There is this next step, which I think might be important for the discussion, because the code will be hopefully approved soon. And then the countries will have to have their translations if they wish, and they will have to define their national annexes. And so the national annexes will be used together with the code. And of course, each country will be free to make some changes. The second issue that I would like to raise for discussion of the panel is I'm a strong believer, as I said before, in research development and in innovation in academia, and the link between industrial cooperation and engineering academia. And so I hope that I'm very happy with the present session today, and I hope we can have more in the future linking the masonry industry and the masonry academics. A second point that I think is important is modern masonry is a very important field of research because there's many people we see here today, many representatives of the masonry industry, which are responsible for many jobs and for many revenues for Europe. Now, I would like to tell you that I'm relatively old, but in the masonry community, I'm relatively young. And this is terrible for the community. And so the community needs to be strengthened. And I think there is a responsibility from the academia, and I'm doing my best to train, let's say, top future masonry researchers, but I think there should be a commitment from the industry. And the industry needs to think that if they don't act, we will stop having a large number of masonry researchers in the future because many other fields are more attractive. Sustainability, IoT, all the buzzwords, digital transformation, and masonry is weakly linked to that in the perception of the young students. The second aspect that I would like also to raise your attention to, I was involved in the code drafting, and to my understanding, this is getting a nightmare for many reasons, because national labs that in the past were a major player in code drafting, they are gone in most of Europe. Governments don't want to support them. And so most people are working at a very limited cost or for free in code drafting. And this is not sustainable. For example, to give you an idea, in Brazil, most people are paid by the industry. And so again, it's very important for the industry to think that you might, let's say, think about insurance sustainability in terms of code drafting in the years to come. And this is also, thank you very much for your attention. I am supposed to introduce briefly the panel and the next presenters. And so the panel, as you might have seen from the program, will be by Rob van der Plujm. He's from Wienerberger, the world's largest producer of bricks and chairman of the Eurocode Masonry Subcommittee. Then it will be Antonio Caballero. He is from the European Calcium Silicate Units Producer Association, and Hans-Joachim Riechers from the German Association from Insulation System, Plaster and Mortar, and finally Cliff Fudge from the European Autoclavated Aerated Concrete Association. So, I mean, I'm very happy, and I think we should all be, to have this very broad scope of panelists together today, sharing their view on what will be the future, and then hopefully having a short discussion with your questions or with the panel, understanding of matters that deserve discussion from my presentation or from the other colleagues' presentation. So I would like to invite Rob to start his presentation. Thank you very much.
Okay, thank you, Paulo. I will start sharing my screen. Good morning. I hope this works. Sure. Yes. Good morning to you all. Thank EuLA for this opportunity, for this good initiative, I think. I will mainly show you the timeline of the next generation of the Eurocodes. Can you hear me or? Okay. So I will present what are we doing or have been done in the past. The next development of the next generation of the Eurocodes, the first initiatives already started in 2010. And then after 5 years of preparation and getting a mandate from the Euro Commission, they supported us with around 60 million euros. So some support from the government for development. Paulo started off with his project team in 2015. And it is not only the Eurocode for masonry, but it is all about all Eurocodes. And when we are looking to the timeline we are now working against, we expect that in 2028, all the Eurocodes have been published and the old generation is withdrawn. So we have to really work with the new generation at that time. So a long time to go yet, but it's not only about Eurocode 6, it is about more than 60 parts we have to develop. And this is a slide just to give you an impression why it takes so long. I don't know what is happening now. It's scrolling up automatically, I have the feeling. The project team started drafting after they have done their work. There is an inquiry that needs translation in German also and in French. We have the English version ready after the work. And then you get comments again. You have to address the comments. You have meetings again to get consensus, because that is, of course, very important that we all agree on what we will get in the future. And then in the end, we have a translation again of the adapted versions, a lot of work, a formal vote, and then finally a publication. And after that, at a certain point, a date of withdrawal. But Eurocodes are, here it is a little bit bigger. You can see it. So I hope you will be able to download the presentations in the end, and then you have a good overview. But it is a consistent package of all Eurocodes. So can we, for example, a question arises if we can work with Eurocode 6 when a new Eurocode 1 or 0 is not published yet? Partly, I think, yes, but will be left up to the countries how they will do it. At the moment, Eurocodes will become available. Probably the Eurocode 6 Part 1.1 will be the first one, hopefully in March 2020, maybe a little bit earlier. Then you can start working on your national annexes, and countries at the end can decide if they want to publish them right away on a national basis, or do they wait until, for example, all four Eurocode 6 parts are ready, or do they wait until all Eurocode parts are ready? And then you have the point when those countries starts to address the new Eurocodes in their legislation, that they have to be used. What is now foreseen is that at least that in March 2028, the idea is that then all old Eurocodes have been withdrawn and we have to work with the new ones. So that is the time scale we have to be ready. It can be earlier, but that is more or less the limit. And then I have one slide with some thoughts about the future of masonry. Paulo has addressed already many aspects. Of course, our big issue of the coming years is the climate neutral 2025 goal setting. And I guess the major challenge for all industries is the production process. How do we get rid of CO2? We have to keep our current pros. We have a versatile material. There is an easy application. Paulo called it old fashions or whatever. For most of the buildings, we can do with very simple calculations, which is also an advantage, I think. We have the challenge of the sustainability, circularity, economy. Do we have to start reuse bricks? Do we have to use dry stacks for that, for easy dismantling? Sustainable use of resources, dematerialization is an topic. Brick slips instead of bricks, Paulo already mentioned it. Is that so bad? I don't know. If we can make the same money as an industry, I don't see the problem. Of course, we have to use much more secondary raw materials coming back from demolishing topics. Another challenge is, of course, the lack of bricklayers in the future, the cost of labor. So we must make major steps in the direction of prefabrication and robotization, I think. Structural demands stay as they always are. And for example, what Paulo addressed about the earthquake, we have to do it really good. But I mentioned here bond strength. For strength and stability, you need coherence in a building. You need bond strength between our bricks and blocks, which is totally opposed to the idea of dry stack. So that is a conflict we have to solve. Another aspect is also, if you just look to facing bricks and the aesthetics of it, over the past 20 years, we see a lot of nasty effects of efflorescence. So we need an evolution of mortars, and in that respect, the current efforts of the lime industry are really good, I think, and I hope it will come out something really good out of that. So that are just some thoughts. We can look to many more dimensions, but that's it for me now, and I want to give over to Antonio now. I stop sharing my screen.
Yes, well, thank you, Rob. I hope you can see me. My screen now, hopefully that works easier. So I hope you see the full screen. Yes.
Yeah.
So yes, as Rob already said, Paulo already addressed a lot of the topics, and you, Rob, yourself also addressed a wide range of the topics that we also see marking our future, or marking our daily life, and the involvement and research also that will be needed in the future. Knowing that would kind of happen. We know each other, and so I was assuming that you would also raise the same topics as I would. I focused just on two of the many that have been mentioned before. There is one, on the one hand, of course, sustainability, environment, and climate. If you want to put it in one package, here indeed, this is what is going to mark the day. This is what is the daily business at the moment. Seeing how we can respond to the challenges ahead of us, 2030, 2050, of course, and looking at how the Eurocode, or what role the Eurocode could play therein. I think, and you said it also, Rob, one of the important things is to have the full potential at our hands. So to really exploit the full load-bearing potential of masonry. Here, of course, we may have to see whether easy or easy calculation models are always the best, or whether we need to go more in detail and more accurate. That will depend. I totally agree that for many of the buildings of today, a simple calculation model is enough. But if we want to compete with other materials also in future, and here I think the trend will be less is more, meaning less material, so resource efficiency also, because resource efficiency comes along in parallel with reduced CO2, etc. We will need to exploit this load-bearing potential, of course, knowing this is what we can do at the European level, and then whatever is left of what the Eurocode offers us after national NDPs apply, after national authorities and regulators come into play and reduce whatever potential is made available for Eurocode. That's of course another thing. I think in this whole arena also the Eurocode 6 needs to facilitate innovation in the sense that it needs to follow product standards. So the products will not be innovated, will not be developed because of the Eurocode 6, but because of the demands of the market. And the demands of the market are, on the one hand, let's say the environmental aspects. You mentioned an increased use of recycled material. The question, will there be, do the equations that apply for the materials we know today apply also for the products in future? So what effects could we expect from using, for example, in the case of calcium silicate, other types of aggregates? Will it have an effect on the load bearing capacity? Yes or no? And to that extent, I think the starting point, of course, is the manufacturer. So manufacturers will develop products, will improve their products based on what they see is the market, what their clients expect of the market, of the products, and this will have to then be taken into account in product standards, and then in the next level to be also facilitated or respected by the Eurocode. I think we all would agree that the standardization route would be the preferential one. So avoiding technical specifications. I mean, if they were European, okay, we might as well discuss whether that makes sense. But certainly, avoiding the fragmentation of the market in national technical approvals. That's certainly not favorable for masonry as a whole, and also not for the common market of masonry. Yes, and in that respect, what I also mean by following the product standards, and here I would like to make a reference to what Paulo was showing with regards to the scatter of load bearing capacity. Of course, we know that at the end of the day, it's about what kind of experience people have with certain products, and it's about traditions, and breaking traditions and experience is a long-term task. But I think the scatter is also related to the types of products that we really have in the markets. When we look at the product standards today, they allow a wide range of products, and in most markets, there is only a small fraction of this potentially possible wide range of products, looking at perforated products in particular. And so therefore, if the national local experience is linked to a very narrow group of products within the wide range that is possible, then your equations may be considerably higher than in the Eurocode, or they may be lower, whatever. It depends how you look at it. And I think in order to exploit this potential, the load-bearing potential, we may need to think about further detailing the groups of the products. In that case, detailing them in the product standards, and then offer a wider range of equations, maybe for, let's say, for the different types that we may have to define. Leaving sustainability and environment, I think the next bus topic for all of us is digitalization, and I include in that, of course, also robotics. What we have been seeing for quite a while in the European sphere is that the amount of information that manufacturers have to supply and the demand for information is constantly growing. There are two trends: either we supply more detailed information, and then no one, well, at a certain point at least, no one is capable of managing that information, or we try it via simplification, and the market response to simplifications are private labels. Now, as an industry, we don't like private labels. So what we have achieved, or what we have through the CPR, is the possibility to declare the performances. And it is an open possibility. It's not restricted to a few. So if there are performances needed in the market, we can do it through the CPR, of course, as long as the Commission plays along. But that's a different topic and not for today. But certainly, where we need to get to, and we're not yet there, is a full digital communication between or along the supply chain. This is a nice picture of Oscar Nieto from Construction Products Europe, which basically shows where the information from our products is used, who needs the information, and it's all nice to have the information in a digital format like Smart CE, but it doesn't help us much if, let's say, the suppliers the actors in the supply chain, including engineers and architects, don't speak that same, I would like to call it, digital technical language. We have the technical language of the CPR, of course, we know that, but we also know that today we have translation issues, meaning that you need to know as a manufacturer, if you're producing your declaration of performance and supplying different markets, you need to have the right terms, etc. In a digital world, that does not exist. In a digital world, we would have one technical expression for a certain property. We are now, as construction product manufacturers, we're now in the process of establishing Smart CE, which is, some call it Smart DOP, it doesn't matter, whatever you want to call it. It's a way of expressing the content of the DOP in a digital and uniform, standardized way. And of course here, the Eurocode of the future, and I'm a bit scared when I look at the timeline that you presented, Rob, whether I will see that come to life and happen. I mean, if the implementation of the currency Eurocodes may take another 5 years or so, I'm getting close to retirement by then. So, but anyway, what will be important is that also the Eurocodes refer to the same digital language that the product standards supply, simply because, and I'll jump back to this slide, simply because one of the things that we have today, and it's even more important, I would say, for sustainability, or within the sustainability sphere than in the structural sphere, but also the structural is important here, is that we have, on the one hand, a design model and a design and a let's say a demonstration of compliance at design stage, but what we often lack is a compliance demonstration at the as-built level or on site. We know it from the past. We've had experiences. I know from myself, from my German experience, my German background, where in the process of introducing energy performance requirements in Germany, we had the experience that for the funding, the design compliance was the valid level. So if the designer could prove that the building would have a certain energy performance, the funds would be allocated. So the public funding was permitted or granted. And then we saw in reality, yes, well, that has been calculated, but this has been executed, and execution and calculation did not match. And certainly in this let's say, well, I'll call it battle. In the battle, in the environmental battle or sustainability battle, I think we all agree that a holistic approach is needed. And then naturally, if we go holistic, someone has to ensure that really the products that have been used by the designer or have been foreseen by the designers are really the ones that are installed. And to close this loop, designers, design codes, products, so product manufacturers need to speak the same digital language. And with that, I close and I pass on to my dear colleague Hans-Joachim.
Yes, thank you very much. This one. So here we are. My name is Hans-Joachim Riechers. I'm representing the German Association for Mortar, for Rendering and Plastering, and for Thermal Insulation. And this picture may show you that we are open for all kinds of masonry. We have always the right mortar for the joints or for plastering, rendering, or for thermal insulation. And that is for more than 2000 years now. And we are quite happy with the Eurocode 6, because the Eurocode 6 is also open for all kinds of technologies, for all kinds of masonry, starting with brickwork, with between laying thermal insulation, or masonry with an external thermal insulation, or masonry where the thermal insulation comes included in the bricks and you need only a lightweight render to cover it in the end. The only thing we strongly disagree in Eurocode 6 is the mortar joint of 0.5 millimeter. That's in our view much too less. A correct mortar joint should always be more than 1 millimeter. We are talking about cementitious or lime-bound mortars, and they need a minimum thickness to develop their characteristics. And that's the reason why we in Germany will have an individual regulation saying that 0.5 millimeters is allowed, but only in a very limited number of points in the masonry, not everywhere. So we will define something like that the fresh mortar, the thickness of the fresh mortar layer must always be more than 1 millimeter, better is 2 millimeter or 3 millimeter. And when in the end, in the finished hardened masonry, there are some individual points less than 1 millimeter, that may happen, that's okay, but not regularly always starting with 0.5 millimeter and ending up with no mortar between the bricks. That will not work. And there we have need for more discussions about this joint thickness, but that's the only point in Eurocode 6 we strongly disagree. In all the other points, I think we agree. That's it. Thank you very much. And I think now it's Cliff Fudge.
Thank you. Thank you, Hans. Let's just put this on. Okay. So going last is quite fortuitous, and I'm looking at the time as well, because I think much of what I want to say has already been covered. So I'm not going to touch at all the Eurocode 6 aspects. I just purely want to look at sort of vision for the future, and let's look at the challenges. I mean, many of these have been spoken about already. I think the green and sustainability agenda is huge. We shouldn't underestimate that. And we've got all these things about, you know, zero carbon targets, carbon emissions, and embodied carbon in particular, I think is something that our industry would be concerned about, but there's opportunities there for us. And there's this threat, and it's picked up by Paulo at the start, from bio-based products, and also the promotion by governments. And I think Paulo mentioned the situation in France, and we're starting to see that in other EU nations as well. And it's sort of an unfair situation for us. You know, we need a level playing field. I don't think government should tell people how to build. They should say, this is how to target. Skill shortages been mentioned as well. And we're seeing this huge promotion of what we call off-site manufacture. And I think we've got some areas that we can tackle on it ourselves. And digitalization, which Antonio covered very specifically in a very good way. So I think what do? We need to build on our strengths. I mean, what we have are fantastic, robust, resilient construction solutions, which, you know, reduce energy use in buildings. One that we don't often talk about, but, you know, responsible sourcing. Our products are sourced locally. You know, we don't use slave labor. We don't transport products from China or etc. But we have other things that are sometimes missed in sustainability, and that's things like acoustics. You know, our solutions are, you know, the finest you can ever get. We don't put emissions into indoor air and not affecting indoor air quality, which I think is a big issue for us. Something particularly for the UK, fire resistance, massive. It's driving our regulations currently. You would obviously have seen the horrendous fire that took place in London a few years ago. That's driving the way that we use insulation in buildings and going forward. Summer overheating, believe it or not, even in the UK, we do get the sunshine in summer. And this year we've seen temperatures of 35 degrees, which has trapped some houses. With the lockdown that we've all had this year, people have been inside their houses, in flats and in apartments. You know, it's almost unbearable. You know, we've got solutions for that. The durability of existing stock. And going forward with renovation, we've seen some of the renovation stuff that's gone on just now. But overall, of course, we do have highly cost-effective solutions. So the opportunities for us, and I think we can probably discuss this in what's left of the panel session coming up, reducing our embodied carbon, certainly through innovation and technology in our own processes in factories, was mentioned earlier. You know, the investment in green energy sources for our plants, you know, sourcing low carbon energy, something that I think we've all got to do. On the innovation side, yeah, we can improve site productivity, digitalization, robotics has been mentioned, a lot of good things that's going on in our industry. We don't necessarily shout about this, but, you know, there is so much that's there. Reduction of waste in our products, and that would include sort of recycling at end of life. But of course, one of the benefits we do have is that, you know, our products are made to last. You know, it's estimated in the UK that the average house built today is going to be there in 150 years' time. You know, we've got the products to do that. Many others, many of our competitive materials simply won't be there. In a single product, in a single solid wall product, we can meet all the demands of strength, fire, acoustics, etc., etc. And we can continue to develop our skilled and competent workforce. And something that we all do, we don't, again, tend to shout about this, is that we tend to engage with our local community on all sorts of business issues. And we do care about our local environment, and certainly masonry, cement, lime industries, you know, we do something about it. So as I think we're sort of slightly overrunning, I think what I'd like to do is just stop sharing that now. And I think we can have our panel discussion, which is going to be facilitated by by Paulo. So Paulo, so it's over to you, really.
Okay, so thank you very much. Well, there was a lot of topics being brought, which I think in a way they are very interesting, and obviously we will not solve today. Well, there is one question that came up, and another question that I am thinking, if some of the colleagues listening in the YouTube would like to add any question, please do it so, because we have a quarter of an hour, 20 minutes to finish. I mean, maybe the first question I would like to hear the panel about, which is, well, we didn't hear much, or even though it was in the background, particularly in Cliff and the fact that many people are buying now in UK to produce wine, but we did not hear much about climate change. And climate change, obviously, we can only talk about scenarios, and it's unreasonable to talk about climate change for tomorrow. You need to talk in scenarios in 20 years, in 50 years. But this is obviously changing the perception of the population fast, and the governments, and well, somehow is a driving force to many of the things we are forced to do. And my question is, I mean, from the industry side, if you can tell us a little bit of requirements that you have, namely in the environmental product declaration, and how you see the future of sustainability assessment. You probably are aware that many softwares now would like to do the sustainability study immediately at design phase together with the full package of design, considering all the necessary, obviously, requirements. I would like to understand how you see this. I mean, I see this, that sustainability studies are very important, not to compare products. And a lot of people use them trying to compare products, which in my view is a mistake. I think you should use this mostly to see how our product can get better. So I would like to hear you a little bit on this, if anybody from the panel would like to jump in.
Paulo, this is Rob. I can jump in from our Wienerberger side, but also from the whole clay brick industry. We have the view that we indeed have to look at the whole building to have the holistic view based on a good life cycle assessment of all the products that go into the building, and that will give you the picture of how sustainable a building will be. And then if you do it at that level, we can also address the claims of the wood industry, and especially the politicians, that such structures are more sustainable than our structures, which, when you do it on that basis, is in fact not the case. If you just look to our longevity as an aspect, if you look to a wooden building, it is not made from wood. It is a little bit made from wood, but there are a huge amount of other products in the building that does not have that same profile as the wood itself. Just to look to the gypsum plates in it to get a proper fire protection, etc., etc. So we are very much in favor of using that approach that is being developed, for example, in the Technical Committee 350, where the product standard EN 15804 to address the sustainability of the products is our major tool to address these questions. And then we have the data that can immediately go into the building when it is designed. And in the Netherlands, we have a kind of tool like that. Our products are in a national database, and an engineer can immediately assess what his sustainability score is. And we indeed have a legal demand on the sustainability score in the Netherlands. But I must admit that the score at this moment is very easy to get, and at this moment does not have an impact on how you have to build, how you have to make your building. But in the end, it will be more severe, and it will have an impact on what we have to do. Okay.
If I may add to what Rob said, I totally agree. I don't know. Do you see my screen now? Do you see? Yeah. Yes. Okay. So this is a slide from Construction Products Europe. Adding to what Rob said, what we haven't been saying lately, and what I believe we need to point out much more actively as a sector, is that the initiative for 350 didn't come from policy, didn't come from the market, it came from us. So the construction product industry has long ago identified the need to have a holistic assessment of a building. As you said it, Paulo, a product-to-product comparison outside the building does not make sense at all. It can, in fact, even lead to wrong decisions and to a less sustainable building. So it was really driven by the construction product sector that EN 15804 was developed, a European standard for replacing the different approaches that we had at national level. And at the end, it's all about providing the information. So having the correct information at the right place at the right moment. This is what the slide shows. And yeah, we are ready to deliver. That's not a problem. We've been asking the Commission for a mandate to be allowed to deliver this information, to go on and present it, because I strongly believe that if we on the one hand call for a holistic approach, on the other hand we need to facilitate this holistic assessment. We can't just say, we need to do it holistically, but not being capable of providing the information, and at the same time knowing that such a holistic assessment is not the general practice at the moment, at least. So we need to move in this direction. And as I said, I think all construction product sectors are ready to deliver. We just need to be allowed to do so.
Okay, I don't know if any of the other panel members would like to go. Otherwise,
yeah, Paulo, I agree with what Rob said. I mean, I think there's a lot of confusion with environmental the profiles because people do carry out a comparison between products, and it is the holistic approach. And if you think about timber buildings, there's a lot more insulation within those buildings, which are high in embodied carbon than necessarily with masonry. And something that we did a while ago, what was done independently, was there was a comparison between a timber frame house and a masonry house in the UK to the same standards of insulation. And the difference in embodied carbon was about 3 or 4%, because we forget that we still have concrete foundations, and we still have roof tiles, and we still actually cover even with timber, we cover the outside with bricks in most cases. But when you started to look at the operational energy requirements, the masonry house performed better because of thermal mass. And eventually you actually got to a parity, So I think there's this myth that other forms of constructions are better, and it's just not there. So I just support everything that Rob said.
Okay, so thank you. We have a question in YouTube. So if the other viewers would like to also add a question, please do so, which is from Andy Smith. And thank you, Andy. And so he's asking the panel. So there seems to be some frustration and some source of masonry issues related to building quality because of the human interface. And so his question, if we tried hard enough to solve this, and what should we do better?
can understand this frustration. To be honest, at least my experience from the calcium silicate industry has shown that when whatever we have done in the past, and I'm talking about starting in the 80s, in terms of improving workability, making it easier, it has not, unfortunately, it has not led to let's say, an improved quality as such, because instead of facilitating the work for a well-educated mason, what the reaction, or how the market reacted to it, was to have less qualified workers doing the same work than before. So I think the issue is not with the products, it's not with us providing products that are durable and can be well handled, whatever. It's really, I mean, our key challenge here is really to ensure educated, qualified workers, and that's of course a difficulty, and I mean a difficulty in modern times. Who wants to go to work sites these days? And that's where, of course, I agree with what Rob said before. Prefab and robotics will, unfortunately, because I still like the human factor, will unfortunately become more and more important in the future. But that's due to a lack of qualified workers.
Could I add something to that? I mean, I think Andrew, one of the things that we're certainly looking at in the UK is there was a concern over construction quality, and certainly in the bricklaying field, and it sort of came about when we were coming out of recession, and there was this real need for quick build, and I think we started to lose quality then. But I've got to say, in the UK, that it's the insurers, and we have a particular insurer called the National House Building Council, and they have put a tremendous amount of time and effort into improving quality on site. And it's done in a number of ways, really. One is that I think when you look at the basic schooling for bricklaying, laying bricks and blocks is the easy part. But the problems that you come across and where the issues are where you have the interfaces and things like cavity trays, drip trays and so on, which if not put in correctly will lead to problems. So I think what's happening is the labour force is being re-educated through sort of hour or two workshops on site with the guys, so it doesn't take up too much time, because if you take a bricklayer off his trades, he's losing money, but if you do it in a quick sort of workshop type approach, that works. But also again, the NHBC are looking at training apprentices, and they're actually building now the schools, and they're calling them hubs, on the major sites. And what happens is these young guys, would have to be young guys, they can be anybody who wants to be an apprentice, but they're being taught in a sort of on the site environment, and so it's part schooling, but they're there for only a few weeks, then they go out on site to get experience, come back into the school. And I think it's a sort of re-education process, and I think this is where we're actually starting to see the improvements come through. And also they run a scheme called Pride in the Job, and that's for all levels of people on site, but mainly at site agent level. And I think when you go to these awards and you see these things, it makes you proud to be part of this industry, because these guys really take care of it. And it looks like when you see Antonio's background when he comes back on again, it's that sort of quality. It's fantastic.
So I think it's not only a question of education, it's also a question of the products we are producing. And I can show you one picture, if I may. And that's a new development in Germany, for example, keeping things much more simple than before. It's mortar plates, dry mortar plates, and you use them, you cover the clay bricks with these plates, you have a watering can, and then you can add the next layer. So this is something that's a new product making things easier. And that's, you have to see a combination of education and good products, simple products.
Can also come back as well in that whilst we might be critical of what we're doing in terms of masonry, we see other forms of construction, even those that are built in factory, that are thought to be of higher quality, but in reality they're not. They're being put together by I've seen I've seen young guys with, you know, nail guns, putting bits of wood together. It goes to site. People think it's fantastic quality. It's awful. And I think we're building up massive problems with some of these systems that are being sold as high quality materials.
Okay, thank you. So now there's several questions coming from other panel members and in YouTube. Maybe I will pick this one. I'm sorry, I don't think we'll have time for all, and then I will leave another one to the end. I mean, one question that I thought it was interesting. We see extremely fast changes normally on directives and regulatory side and on validation of performance, but less in the structural part. And it is a bit scary that the Eurocode develops, I mean, they take so long to change. We're talking about 20 or 30 years maybe, whereas other directives and other like thermal or acoustics or others are much faster to change. And so a question is this a problem for the industry? Which maybe, and the question is also linked to the new Eurocode. So will it help innovation, or at least will it not be against innovation? And this is what I would like to ask to the panel.
But perhaps I should start, Paulo, on this one. With regard to innovation, if you look to, it's about using new materials, huh? And if you look to the principal approach of the Eurocodes is that you can get your material properties by testing masonry. So if you have a new material, you can do the test on it, and then you can, in principle, apply it. So in principle, I think the Eurocode itself is open. The principles of buckling, etc., are not so much dependent on the type of masonry you use, etc. So I think it is in principle a very open system. The problem is, of course, that in daily practice, an engineer wants to know its property very quickly, and it cannot be hardly be done on a basis of a particular building, but it opens the real possibility for industry to do it. And I think if I look to my own industry and my own company, Wienerberger, we have developed a system based on replacing the mortar, sorry EuLA for this, by polyurethane to really improve productivity. And it can be done using, you have to establish your material properties, and then you have your means to use the rules of the Eurocode. So, and then of course in many countries you need approvals for it, but you can use the same methodology of the Eurocode to use such modern materials. Okay. That's my reaction.
Okay.
You're reading questions.
So, I mean, I have so many questions here that I don't know exactly what to ask. Maybe I would ask a very short question on why do you think lime is being less used today than it was used in the past?
So we don't think that lime is not used so much in the present. What we see in Germany is that lime is used more and more, especially in the field of internal plasters, because it has, with lime, it's a little bit like with wood. Everyone thinks it's a very ecological material. So it does not depend on real facts, maybe, but we see that there is a very growing interest in these lime products, especially for internal use.
Yes,
So,
and
so
from my
Hans,
side,
yeah, sorry,
oh,
go.
sorry. Yeah, and from my side, I would say it's difficult to generalize this perception. Of course, for the calcium silicate industry, and I think this is also true for AAC, Cliff. The tendency is clearly towards thin layer mortars, where you are more cement based than lime based, of course. But yes, I would agree with Hans-Joachim that also in the calcium silicate industry, we do like to see lime-based renders rather than gypsum-based renders, because it facilitates recycling in our case.
Yeah, you covered the same point I was going to cover, Antonio.
Okay, so thank you very much. We are exactly on time. I am sorry that several questions remain unanswered, but I'm hopefully, well, I hope that this can be continued in the other sessions. I thank you all in name of EuLA for participating, the panel members, and again, EuLA for the invitation, and also the YouTube viewers at the moment. And of course, the session will remain recorded for others to access. Thank you very much.
Okay.
Thank you.